Welcome to video 52 about asteroids, and I'll come to this little picture over here in just a second. Don't let it distract you too much. I want to tell you that back in the early 19th century, like the 1800s, actually late 18th century, early 19th century, astronomers were looking for new planets, right? They had just discovered, Uranus. Neptune had not yet been discovered, but people were looking for new planets. And one place that they really wanted to look was between the orbits of Mars and Jupiter. There was a big gap there, and this sort of bothered people why there was such a big gap. And they thought, well, maybe there's a planet in there, right? Something small we hadn't seen before, right? They just discovered Uranus a couple decades earlier. They thought, well, why not more? If there's one that we haven't seen before, why not lots more? So people were looking everywhere, but at this point in time, astronomers were mostly looking between the orbits of Mars and Jupiter, and they found some stuff. 1802, they found an object named Ceres, orbiting at about, I think it's 2.8 AU from the Sun. That's pretty squarely between the orbits of Mars and Jupiter. And then shortly after that, they found, they put them in order here, Pallas, P-A-L-L-A-S, Juno, and Vesta, all orbiting between Jupiter and Mars and Jupiter. So 2.8, 2.8, 2.7, and Vesta's a bit further out, 3.4, but still well inside between the orbits of Mars and Jupiter. So all these new things came up. So basically Ceres was found in 1802, and sort of in the next few years, these four were found. And so the number of planets started adding up. And so for a while there was a planet, there were 4 planets considered between the orbits of Mars and Jupiter. The number of planets that we have called planets has bounced up and down a lot over history. And during the early part of the 1800s, it was believed that there were 4 new planets orbiting between Mars and Jupiter. And it turns out these are quite big as well. Let me put these numbers up here. 600 miles across for Ceres, 400 for Pallas, 85, it's a smaller one, 85 miles across for Juno, and Vesta was up at 360. So these are large objects, big enough to be, spherical in shape. And so it's very exciting for everybody. But we kept discovering them. And so today, there's about 1 million known asteroids. About half of those have had orbits that have been that are well known. 1 million of these things, and most of them do orbit between Mars and Jupiter in what's known as the main asteroid belt. Sometimes this is called the asteroid belt, but there are asteroids in other places as well, not just in that belt. So it's sometimes called the main belt. Main belt asteroids are the ones that show up in the orbits between Mars and Jupiter. But there are plenty of rogue asteroids out there too, as we'll see in just a minute. But there's about 1 million asteroids. The orbit's eccentricities are between about 0.03 and about 0.3. So they're fairly eccentric orbits, okay? But they stay, the main belt asteroids, again, these are main belt. These are the eccentricities of main belt asteroids. They stay inside. They stay with the team. They stay with the crowd. They don't get radical. And so, let's see. The total mass of these, is very low. It's less than 1/100th the mass of the moon. Okay. So you add all the masses up, you don't get very much. It's not a significant amount of stuff, but there's just a lot of it, and it's spread out all over the place. Okay. So you have your main belt asteroids, and I think that's all I wanted to say before I moved on. Make sure, yeah. There are also asteroids that orbit within Jupiter's orbit, 60 degrees behind it There's a small group that orbit behind Jupiter in Jupiter's orbit, and a small group that orbits out in front of it, 60 degrees in front of it. These are known as the Trojan asteroids. They actually orbit within Jupiter's orbit. Okay, so they're co-orbital is the term for that, with Jupiter. They all move around with Jupiter. They stay 60 degrees ahead of it. By 60 degrees, I mean the angle between the Sun and Jupiter and the Trojans in front is 60 degrees, and the angle between Jupiter and the Trojans behind it is also 60 degrees. They orbit along with Jupiter. These are stable places, so if you take a rock and put it out there in that location, it'll stay there as long as it keeps moving around with Jupiter. Lagrange points is the actual mathematical term for it, but those are points of stable orbits, and so you get a little group of Trojan asteroids ahead of and behind Jupiter. So that's a group of asteroids that are not part of the main belt. Okay, but their orbit stays with Jupiter, so they don't really go very far. There are others that fall within the orbit of the Earth, known as Earth-crossing asteroids. And these are the ones that we need to pay attention to. There's actually many of them. And what they may have is an orbit that looks something like this. They may have an orbit that follows something. Maybe this is one right here. You can pick a different color, maybe the green color. This Earth-crossing asteroid here may have an orbit, a very eccentric orbit that looks like this, around the Sun like that. You know, it's an ellipse, but it crosses the Earth's path, or at least comes within 1 AU of the Sun. Okay. And so these are the ones that could potentially, now some of them are in orbits where they're never going to create trouble for us, but some of them are in orbits that could create trouble for us. Okay, there's Earth-crossing asteroids, and then there's another group known as the near-Earth. And those are the ones that we need to be concerned with. So near-Earth asteroids are a subset, compose a subset of Earth-crossing asteroids. Some Earth-crossing asteroids that come within the Earth's orbit are in orbits that were never going to threaten us, never come close to us. But the near-Earth asteroids are potentially hazardous in the future. If you ever want to have a good time, go Google near-Earth asteroids, and NASA has a list of them. There's thousands of them. Some of them are big, some of them are small, but all of them are close enough to the Earth to register on that list. Okay, so there's a lot of rocks out there. And there's also some asteroids that fall within Mars's orbit. Those are known as Amor asteroids that fall, don't cross the Earth's orbit, but cross Mars's orbit. There's a whole bunch of different classifications of asteroids out there. And there's some that swing out a little bit beyond Jupiter, but there's plenty that come within the Earth's orbit. Okay, I don't know the numbers. My guess is it's probably in the tens of thousands somewhere. That's not near-Earth asteroids, that's Earth-crossing asteroids, probably in the tens of thousands somewhere, known as Apollo asteroids or A10 asteroids. So, there's lots of asteroids out there. All right, and most of them, as I've indicated in the picture here, orbit along in the same direction as all the planets. These blue arrows show that they're orbiting along with all the planets. Where those came from, it's believed that it's pretty much known, the evidence is overwhelming, that the early solar system was a lot more like the asteroid belt than it is today. Imagine small chunks of rock everywhere. And some of those small chunks of rock got built up into larger planets. And of course, the larger when they collided and they stuck together because of gravity, they tended to attract more chunks of rock. And so they piled up into the planets. It's the overwhelming gravity of Jupiter, we believe, that has kept the asteroid belt from coalescing into planets over time. Without Jupiter, we wouldn't have the asteroid belt. I do want to make one last quick comment about asteroids. There's really three types. Let me see, I don't really have a place to put this. Let me make it a new color. Let me make it pink. There are C-type, which are the most common. There's the S-type, and there's the M-type. C stands for carbon, and that simply means there's lots of carbon. S-type means silicon. That essentially means for us that they're very rocky and less heavy with carbon. And M-type has a lot of nickel and iron, very heavy elements. Okay. The C-type is the most common, 75%. S-type is less common, about 15%, and M-type is the least common at about 10%. Turns out the C-type is the darkest ones, the ones that are hardest to find. Okay. S-type are more reflective, have a higher albedo, so they're easier to find, even though there's fewer of them. And M-types are somewhere in between. They vary a little bit, but they're somewhere in between the two. Okay, but these are the three major types, and of course they're broken down. The three types have to do with composition of the asteroids. And the last thing I need to tell you is what I should have told you at the get-go of video 52, is that asteroids are defined as rocks orbiting the sun that are not planets. Okay, we'll define planets. We still haven't defined a planet yet. You notice that? We still haven't defined a planet. But basically, there are rocks orbiting the sun. Okay, they are rocky, not icy. Okay, that orbit the sun, that are 100 meters across or more, which is about 330 feet across or larger, are classified as asteroids. There's a whole lot of other rocks orbiting the sun which are way smaller than that. They're known as meteoroids. We'll pick those up soon enough. Okay. But asteroids are typically large, 100 meters. You know, basically 100 meters, think of like a football field including the end zones. Okay. And they come in all kinds of crazy shapes. They're not all round. Only the largest ones are actually spherical. Smaller asteroids, which is virtually all of them except for these four here, can be shaped like, you know, potatoes or like walnuts or whatever. They come in all kinds of oddball shapes, and some of them have moons. So there's all kinds of odd-looking things you can find. If you Google images of asteroids, you'll find a huge array of sizes and a huge array of shapes. Okay, and these things are out there, but they're not as close together as it appears on this drawing. We send space probes out through the asteroid belt and never have to worry about hitting an asteroid. So a lot of sort of cartoon pictures you see of the asteroid belt looks like it's a bunch of rocks real close together, but they're super far apart. And if you were to travel through the asteroid belt, the probability of being hit by an asteroid would be basically zero. Okay. You take a lot more risk when you drive on 285 in your car than you would going through the asteroid belt, you know, risking being struck by another asteroid. So that's it for the asteroids. Next up, comets.